Okay, answers to homework. Okay. Three. As I stated the other day, you guys do an outstanding job of writing your limit statements. I don't think anybody missed because of writing the statement. You may have got the wrong answer, but it wasn't because of the statement. You should have had infinity 0 for number 1, 0 negative infinity for number 2, and then 0 infinity for number 3. Number 4 was infinity, way too far. Infinity 0. Number 5 was 0 negative infinity, and number 6 was negative infinity 0. So all these were just left and right bounds. So it should have been negative infinities for the limits. You had to match those. So I don't know if you matched it via numbers or via, but this one should have been number 4. So number 7 and number 4 went together. Number 8 and number 3 went together. Number 9 and number 2 went together. And then number 10 and number 1 went together. So you should be familiar with that information. Number 11, you just had to draw one. It could have looked anything. It didn't have to be down below. It could have been anywhere. And same with number 12. It could have been anywhere. So you just had to draw basically an exponential decay and then a flip of an exponential growth. And then number 13, decrease without bound. The output decrease with it as the input values increase. So it gets closer to 0. So that one should have been very similar to that. You could have hit the y-intercept anywhere, but it should have been pretty close to that. Okay. And then number 14, it should have looked very similar to that. It should have hit the y-intercept at 5 because it says the k value or the initial value is 5. Okay. Questions like you're going to see on your test, it will be a multiple choice question. So it'd be like these. Guys, when you're studying these, again, don't necessarily, don't focus on which one's right, focus on why the other ones are wrong. Okay, so when you're studying, when you look back over this stuff, when you guys are preparing for the test, don't just, oh yeah, that was C, or make sure you focus on which ones are wrong and why they are wrong, and maybe even sketch those 3, if that kind of makes sense. Because that's like 4 questions in one. So number 1 should have been C. 2 should have been C. 3 should have been D. 4 should have been A. 5 was D. 6A. 7 B. 8 B. 9A. Anything I need to show, explain better, different, anything to help you understand this. I hope this was fairly easy. It should have been. Should have been. A little bit confusing on the negative. Sometimes that flips your brain a little bit. So you have to think about those. Yes, ma'am.
Is there a situation where the B value is 0 and 1?
The B value? What's the B? The base? This one?
Yeah. Is there a situation where it's like between 0 and 1?
Yeah. Yeah, that's a decay. Yeah, absolutely. That one's a growth just by barely because 3.14 is bigger than 3. It will never be negative. I think I mentioned that because you can't have a negative to an exponent that's a variable because it just makes things really, really weird. Really weird. to do to the, oh, here. Yeah, see, I don't know if you can see that. It's just a bunch of dots. And it's still a function. It's just, you'll never, ever, ever see that. Okay. I didn't know Desmos would even graph it. Uh-oh. There. Anything over 2.3, 2.2, 2.1. Everybody okay? Good, 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 good. 2.4 is when it starts getting a little bit more difficult. Students have some issues with 2.4. So let's go with 2.4. So our goal today, we'll do 2.4. Put everything away, and we're going to go over our tests, and then I'll give you 2.4 as homework. Wednesday, I'm going to give you a review / worksheet from 2.1 to 2.4. We're kind of a day ahead, and the other pre-cal teachers aren't here today. So that will put us a day ahead. So we'll just kind of review on Wednesday, have a nice little break, come back refreshed for Monday. Is good? Okay. So 2.4 today. 2.4. 2.4. Exponential function manipulation. Notice it says a big word, manipulation. Basically, we're transferring some stuff around. We're making it look differently. And like I said, students, I don't say probably, but I'm just going back 2 years ago from my memory. I remember this being a highly missed question on the test. So just focus on this. I don't think it's that difficult. It's nothing you don't know already, but it's something different than you've done previously. I think you guys know the product property. When you have two bases that are the same, b and a b, and they're both raised to exponents, you can add the exponents. So there's mb's and there's nb's. And so let's do it like this. There's 5x's and there's 3x's. So there's 5x's and 3x's. So when you put those together, basically there's 8x's. I don't really know the rules as much as per se. I just kind of count the x's. There's 5 of them, there's 3 of them, you're putting them together, so that's why there's 8 of them. Now, this is what you're going to kind of see. This is what you're going to kind of see today. This is 2 to the x and 2 to the 3. So this is where you need to know you need to multiply those together, because there's x2's, which doesn't make any sense, and then there's 3 2's. And so that ends up becoming 2 to the x plus 3, which is what you guys saw in some of the homeworks previously, right? So 2 to the x plus 3. When it's a power to a power, we know we multiply the exponents. So the power to a power, we multiply them. So there's 5x's, but you're cubing them. So there's 5x's 3 times. That would make 2 to the x 3, 2 to the 3x. Again, that's probably, this is the more important. This guy, you know this stuff. And you know this, it's just, we're going to take it from the right-hand side to the left-hand side. We're going to take this from the right side to the left. So that's what's going to be different for you guys. You're used to seeing it from this side to this side. That's what you guys have done. Not really this. You've done this. You've taken it from this to this. We're going to take it from this back to this one, which is why it's different. Okay? And then the negative exponent. And all a negative exponent will do is basically put it in the denominator and make it a positive exponent. So a negative exponent just puts it in the denominator and makes it a positive exponent. So if it's x to the negative 3, you can make it 1 over x to the positive 3. If it's 2 to the negative x, you can make it 1 over 2 to the positive x. So if it's a negative exponent, you just basically put it in the denominator. If there's nothing in the numerator, you got to put a 1 there. If it's ever negative in the denominator, you can put it in the numerator. That's ACT stuff. If it's negative in the denominator, you can put it in the numerator. Make it positive, because you're just dividing it again. Okay, so 3 rules you need to know. The product property, which you guys already know already. The power property, you know all 3 of these. It's just, we're going to take it to a different level. So here's example number 1, okay? Example number 1. Determine the horizontal transformations. So we know that 4 makes it a exponential growth. Okay, 4 makes it an exponential growth. To the x, 4 to the x. Well, then we got a plus 2. So all that does to this whole entire graph is move it. Let's see, that number's with the x. So anytime it's with the x, it does opposite of what we think. So it's going to move it to the left 2 units. And that's all we're going to have to say on that. Shifts it negative 2 units, shifts it to the left 2 units, however you want to say all that. Determine the horizontal transformations of each of the following exponential. They shouldn't have to say horizontal. They should have just said determine the transformations. You guys should know that that's a horizontal because it's with the x. So left 2 units. That one's with the x, and it's a 3, so we multiply it by 3, but remember if it's with the x, it does opposite of what we think. So it horizontally, what do we call it? Horizontal, and everything's a dilation by 1/3. Always opposite of what you think when it's with the x. I don't want to say opposite, but so the next one we have x divided by 2. Now we ought to be able to easily see if that was divided by 2, that's now going to be a horizontal dilation by 2. Doubled. Horizontal dilation by a factor of 2. Horizontal dilation factor of 2. Oops, of 2. Get there. There you go. And then D should be fairly easy. We're going to shift that thing to the right 1 unit. Horizontal translation by right. That work. 1 unit. Easy peasy. Exponential growth, exponential growth, exponential growth, exponential growth. All 3 of those are exponential growths. So they start this way and look this way. You will not be able to tell the difference in B and C. Because when you dilate it by 1/3, instead of it just going up here, it just kind of, it shrinks it in a little bit, but you can't tell that a whole lot for an exponentials because they grow up so fast anyway. Okay, beautiful. That's just the graph part. Okay, that's easy. Now let's re-examine the exponential functions in example 1a and see if we can use our exponent properties to rearrange the function into an equivalent form. So this is what you're going to see right here. We can use the product property to reverse to show that 4 to the x plus 2, 4 to the x plus 2, by reversing what you already know, that's the same thing as 4 to the x times 4 to the second. It's the same thing, because if you add exponents, that's the same thing as multiplying the 2 bases. Well, 4 to the x is going to stay 4 to the x, and 4 to the 2 is 16, 4 to the x. So now you need to also see this. If you see 4 to the x plus 2, you need to know that's the exact same thing. I don't know what's going on here. Is 16 times 4 to the x. Whoa, dadgummit. Those are the same thing, guys. This and this are the exact same thing. This is a shift to the left 2 units. This one is a multiply the y units by 16, right? That's a vertical dilation by a factor of 16. So a vertical dilation by a factor of 16 is the same thing as just moving that thing to the left 2 units. Yeah, okay. If I draw this graph and this graph, they're going to be the exact same graphs. So you guys need to know how to turn it from this to this, because a lot of times we're not going to see the horizontal transformations. We want to change it to the vertical transformations. And that's what they're going to say. Like they're going to throw all that in there and you guys got to put all that together. Okay? So this and this are the same thing because this is the same thing as 4 to the x times 4 to the second because you can undo that. Okay. This means that 4 to the x plus 2 is equivalent to writing f of x is equal to 16 4 to the x. So that's a big deal. Big deal. We can rewrite the exponential function this way. There's no longer a horizontal transformation, but now we have a vertical dilation by a factor of 16. So same thing said, different ways. All right. So that being said, important idea. Every horizontal translation of an exponential function is equivalent to a vertical dilation. Every horizontal transformation is equivalent to a vertical dilation. So the left or right is the same thing as a stretch or shrink. Okay? Have to kind of put all that together. So here's example number 2. Each of the following exponential functions has a horizontal translation. For each, rewrite an equivalent representation that has a vertical dilation and no horizontal translation. So that's kind of what they're going to say. You can see the difference between rewrite this so that x doesn't have anything with it. So this is 2 to the x plus 3. So I'm going to change this to 2 to the x times 2 to the third. If I say 2 to the x times 2 to the third, this is what you guys did your whole mathematical career. Rewrite that. That would be 2 to the 3 plus x, or x plus 3. Well, now we're undoing it. And so that 2 to the x is going to stay 2 to the x, and the 2 to the cube is going to change that now to an 8. So when I rewrite it, it's going to be f of x. Don't forget to put that part of it. We always put the integer first, and then I can put 2 to the x. However you want to do that. Don't make it 16. Don't make it 16. What happens? You get the wrong answer. I'm not going to hit you with a ruler. No. Remember? Because you're no good to society. You're going to see that on some of your tests at some point. I haven't done it yet. All right. So 3 to the x plus 2. Sometimes you can do this a little bit easier, but I'm going to make that 3 to the x times 3. Is that a minus 2? So that's a negative 2. Sorry. I'm just going to make it 3 to the x times 3 to the negative 2. And now 3 to the negative 2 makes it 1 over 3 to the positive 2, which is 1/9. So g of x will be 1/9 3 to the x. Don't make that 1/3. Now this one already has a 4 there, so I'm just going to put that 4 over there and kind of leave him by himself. What's going on? There you go. And then I'm going to go over here to this side and make it 3 to the x times 3 to the 2. And that 3 to the 2 makes the 9, and I'm going to put that 9 with that 4 because we can do that. So the 9 goes with the 4. That's going to make a 36. So I have k of x will equal 36 times 3 to the x. Beautiful. Beautiful. Y'all got questions? You okay? This and this are the exact same things. You just, I can't tell you how tricky that is on the test. It's just, you got to be able to see that. Okay? Beautiful. All right, what else we got? All right, another page. We also use the power property of exponents to show that every horizontal dilation is equivalent to changing the base of the exponential. Okay, changing the base to an exponential, because you know that b to the cx is the same thing as b to the c to the x, because it's a power to a power. Nah, that's probably more confusing than just looking at the example. So here's the example. Which one of the following functions is equivalent to 9 2 to the x? Well, you need to see that 9 2 to the x is the same thing as 9 to the 2, what, to the x, because that's a power to a power. This 9 2 to the x is the same thing as 9 2 to the x. Well, 9 to the 2 is the same thing as 81. So you can make that 81 to the x. So you go over here and 81 to the x has to be d. There's no way 9 to the 2x is the same thing as 3 to the x, I hope, because 3 to the x is 3 to the x. Like, you can't do anything to 3 to the x. So there's no way a 3 to the x can be 9 to the 2x. 3 times 9 to the x, yeah. And don't make that 27. So 3 times 9 to the x, that won't be 3. That would be the 1/2. If 9 was to the 1/2, that would be 3. You okay, right? Because that's the square root of 9. 18, they're trying to get you to multiply these things together. So it almost doesn't make sense to any one of those. Maybe that one. Okay? Again, not necessarily which one's right, but why the other ones are wrong when you're doing homeworks. Don't focus on which one's right. Focus on making sure one of the other ones are wrong. Which of the following is equivalent times 9 times 4 to the x? So I look over there and I see a 3 and a 16 and a 3 and a 16 and a 9 and a 16 and a 9 and a 16. And this is a 9 and a 4. Okay? And this is to the x, and that's an x to the 1/2, and there's a 2x, and there's an x to the 1, or x over 2, and there's a 2x. Yes? I'm kind of looking at my answers, trying to decide on how I want to do this. So 9 could be the same thing as 3 times 3. 4 can be the same thing as, let's see, let's go 2 to the 2x. Because everything over there is, I got 16s, I got 2. I don't know if that's going to help me any or not. Let's see. This is 3 squared. How about that? Yes? And 2 to the 2x. What else have I got going on there? Sometimes it might be easier to go from your answers to this. So let's go over here and look at this. 3 times 16. Let's see, that's 16 to the x to the 1/2. Let's do that the other way around. Let's make that 16 to the 1/2 to the x. Sorry, 16 to the 1/2 is 4. So now we end up with 3 times 4 to the x. That's not what that is. That's not what that is. So this one says 3. I don't think it's going to be this one, because I'm just going to end up with that 3. Yeah, okay, I need a 9. So I don't think it's going to be this one or this one. I need a 9. So I got a 9 and a 9. Let's go with that. This is 9 times 16 to the 1/2 to the x, and 16 to the 1/2 is 4. I think that one's it. You'll kind of see how it did that. Sometimes it's better just to go from your answers to that than it is from that to your answers. This one is the same thing as, that's 16 squared. That's a big number. It's not 4. Okay? Beautiful. 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 Does the next page say 9.5? 2.5. Okay. Y'all are paying attention. That's all there is. Manipulation of these things. It seems easy when I do it. It's going to seem easy on the homework. Boy, I don't know what happens on the test. So star this section. Do what you got to. All right. Beautiful.